typical 120/240 volt residential electrical system is generally not considered a separately derived system. To understand why, let's define what constitutes a separately derived system and then contrast it with the common configuration found in homes. A separately derived system is an electrical source, such as a generator, transformer, or solar inverter, that has no direct electrical connection to the primary power source except for the equipment grounding conductor. This means the secondary side of the transformer, for example, is electrically isolated from the primary side. The neutral conductor of a separately derived system is typically bonded to ground at the source, creating a new grounding point. This is in accordance with the National Electrical Code, specifically Article 250. Typically, in a separately derived system, a bonding jumper connects the neutral conductor to the equipment grounding conductor at the source, like a transformer. This establishes a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. Now, consider a typical 120/240 volt residential service. In most cases, the power comes directly from the utility company's transformer, which is located outside the home or nearby. The utility transformer's secondary windings provide the 120/240 volt service. The neutral conductor is grounded at the transformer, and this grounding connection extends to the service panel in the house. The key difference is that the residential service panel is not a separately derived system because it's directly connected to the utility transformer's secondary windings. There isn't a separate source of power within the home that is electrically isolated from the utility supply. The grounding and bonding in a residential service panel follow specific requirements outlined in Article 250 of the National Electrical Code. The neutral conductor is bonded to the metal enclosure of the service panel, and a grounding electrode conductor connects the panel to a grounding electrode system, such as a ground rod, ground ring, or connection to a metal water pipe. This grounding electrode system provides a path to ground for fault currents and helps stabilize the voltage to ground during normal operation. Because the residential service panel is directly connected to the utility transformer's secondary and the neutral is already grounded at the transformer, it does not meet the definition of a separately derived system. Separately derived systems are more commonly found in commercial or industrial settings where backup generators, transformers for different voltage levels, or renewable energy systems are installed. For example, if a building has a 480 volt service and needs 120/208 volts for lighting and receptacles, a step-down transformer would be used. The secondary side of this transformer, providing the 120/208 volts, would be considered a separately derived system, and the neutral would need to be bonded to ground at the transformer. Another example would be a generator. When a generator is used as a backup power source, it is often configured as a separately derived system. The generator's neutral conductor is bonded to ground at the generator, and a transfer switch is used to isolate the generator's power from the utility power when the generator is running. This prevents circulating currents and ensures proper grounding and bonding. To summarize, the main characteristics of a separately derived system are electrical isolation from the primary power source and a new grounding point established at the source of the separately derived system. A typical 120/240 volt residential system supplied directly from the utility transformer does not meet these criteria. The neutral is already grounded at the utility transformer, and the service panel is directly connected to the transformer's secondary windings. In residential applications, it's crucial to adhere to the grounding and bonding requirements specified in the National Electrical Code to ensure electrical safety and proper operation of the electrical system. This includes properly bonding the neutral conductor to the service panel enclosure, connecting the panel to a grounding electrode system, and ensuring that all metal parts of the electrical system are properly grounded. Understanding the difference between a separately derived system and a standard residential service is essential for electrical professionals and anyone working with electrical systems. It ensures that grounding and bonding are done correctly, which is critical for preventing electrical shock hazards and ensuring the reliable operation of electrical equipment. For further clarification, always refer to the latest edition of the National Electrical Code and consult with a qualified electrician.